A stored procedure in prod was freezing the application. It took around 40 seconds to run and it caused the application to time out. I spent some time investigating it, made a few targeted changes, and got it running in under 1 second. In this video, I'll walk you through exactly what was wrong, what I changed, and the lessons you can apply to your own SQL. This stored procedure was responsible for finding records that weren't linked in a specific hierarchy in the system. On the surface, that sounds simple. However, it ran in 40 seconds and was causing the application to freeze, and people couldn't complete their work in this part of the application. The first thing I did was run the execution plan. I ran this when I called the procedure. SQL Server Management Studio showed a series of execution plans, one for each query in the procedure. I think there were maybe 10 execution plans shown. I scrolled through the output, taking a quick look at any of the plans to see if any stood out as taking up a large percentage of the entire script, or if any were very large or were missing indexes according to the hints. Nothing really stood out to me at first glance. There wasn't a query that was taking up, say, 70% or 80% of the runtime. The steps look pretty evenly spread, so the problem could be something else. When I opened the SQL Server stored procedure, the first thing I noticed was the length. It was about 500 lines of code. For something that found records that weren't linked, it seemed like it was too much code for what was probably something that wasn't that complex. The first thing I did was to read the procedure and understand it. Now, I won't show the actual procedure code here because it would be a breach of privacy and data protection to do that, but I can explain the general concept of it. The procedure used a series of temporary tables that were populated from some queries. I first read the queries to see what they were doing, and then I ran each of them in a new query tab to see what the results showed. I was looking for a couple of things here. I wanted to see how long these queries were taking, so if there was a long runtime for a specific query, I could notice it. I wanted to see how many rows were returned, so I could see if there was a lot of data to process. I also wanted to better understand the overall procedure, and a good way to do that is by running these queries. Once I did this, I went back to the stored procedure. I was beginning to understand what these queries were doing, but I didn't find any query that took a long time to run. That was okay though, because I had a few different ideas I wanted to try. I kept looking through the procedure and noticed one part of the structure that stood out. There were 2 nested loops. Each of the loops used a cursor, which is kind of an object that retrieves rows from a database table and then was used in a loop to iterate through and then process each row. At this point, a little red flag appeared in my mind. Not literally on the screen, but something I realized. Any time you're using loops in a stored procedure, it's likely going to perform poorly, and there's likely a better way. Not every time, but most of the time. So once I understood the structure of the procedure, it was time to measure the performance. One of my favorite ways is to put print statements at several points in the code and run the code as a script instead of a stored procedure. This meant I would remove the create procedure command and just have the script run by starting with some declare statements and then into the code. I had to add a couple of declare statements to declare the variables used for the parameters, then a couple of set statements to set these values. Then I used a series of print statements to print 2 things. First, a unique number, which indicated which point of the code the statement was printed from. This was done just by printing the number 01 first, then on the second statement I used 02 and so on. Then I added the current timestamp, which had the current time in hours, minutes, seconds, and milliseconds. This meant I could view the specific moment that each line was printed. I think I had to use some kind of conversion function to convert the current timestamp value into a text value or something that could be added to this print statement. Why did I do this? It's so I could measure which parts of the code were slow. I could compare each printed line with the previous line and find out which area was the slowest. I did this and put maybe 20 different print lines in the code. Then I ran the code. This script ran in about 40 seconds, according to the little status bar in SQL Server Management Studio. It showed the results that were supposed to be shown in the results panel, which were maybe 5 different records. Then I went to the Messages tab to see the output of the print statements. It looked like this. There were 20 different lines with dates and times. Now, normally I put this into Excel and use some string manipulation and some formulas to find out which part was the slowest. But in this example, I could see which part was the slowest. It was this section here. I could tell because between line number 17 and the previous line number 16, there was a difference of about 38 seconds. This was out of the overall runtime of 40 seconds, meaning the code in this step took almost the entire runtime. The code between the print 16 and print 17 lines was the slow part. So what was this code doing? I looked back at the procedure and saw it was a nested loop. I had this statement before and after both loops just to see if it was actually the slowest and not from a different slow select query. But it was the loop. So I knew it was here that it was slow. Then I had to work out why it was slow. Now earlier I mentioned these loops were using a cursor, and a cursor is populated with the data from a select query. So I looked into the code that was populating these two cursors. There were two select queries. The first select query returned about 7 rows. These rows represented the possible unlinked rows. The second select query returned about 500 rows. These rows represented the possible links to these unlinked rows. And because these were nested loops, meaning one loop ran inside the other loop, the loop that returned 500 rows was run 7 times. Then, for each row in that 500 row loop, there was some code that was run to add a record to another temp table. So we had this code that was being run 500 times within another 7 iterations, bringing the total executions to about 3,500 times. This code in the middle of the loop wasn't slow by itself, but it was being run 3,500 times. Even if it ran in 10 milliseconds, being run 3,500 times would take about 35 seconds. This was it. This was the slow piece of code. This is a classic example of row-by-row processing. SQL databases are built to work with sets of data, not procedural loops. Each iteration adds overhead, context switching, and repeated work. What's important here is that looking at the execution plan for one query inside the loop would not show the real problem. We saw this earlier when I ran the execution plan for the procedure. The issue was the overall process, not a single slow statement. Instead of trying to optimize the loops by looking into the performance of the queries that populated them or the data being returned, I tried to eliminate the loops. I stepped back and asked a simpler question. What is this stored procedure actually trying to do? At its core, it was trying to find records that didn't have a related match. I thought this could have been done better without the 2 loops. The next step was to rewrite this query that was using these loops to get the same results using a single SQL statement. This took me a couple of hours. I started slowly with a simple query and then expanded on it with different keywords and logic to get the results I needed. I struggled a bit with this, trying to get the right combination of not exists and joins and different criteria. However, I got a query written in a couple of hours that seemed to work. I rewrote the logic using a single select statement with a not exists clause. This query returns all parties that do not have a matching record in this other linking table. Instead of looping through rows and checking conditions one by one, the database does the work in a single pass using set-based logic. This is what relational databases are designed to do. So I ran the updated select query. The runtime was less than 1 second. It was faster, but was it correct? Anytime you rewrite logic like this, testing is critical. The overall result was the same. It still showed the same records as earlier, but I needed to test more. I compared the row counts from the old stored procedure and the new query. I also spot-checked individual records to make sure the results matched the original intent. Only once I was confident the data was correct did I move on to enhancing the stored procedure with the new code. I added this new query to the create procedure command and then created the procedure on the dev environment. This meant if I broke something, it was okay and I could revert it easily. I executed the procedure and it ran in under 1 second, though it was on dev. So far, so good. So then what happened? I worked with the development team to get the code promoted to the testing environments to go through the normal deployment process, and it was all okay. It was then deployed to production. The new query ran once instead of thousands of times. Execution time dropped from about 40 seconds to under 1 second. Even better, it now scales properly as the data grows. The production timeouts disappeared, and the application became responsive again. I suspect this query had always been slow. The reason for the code being slow was the number of loops over a certain piece of logic. The number of loops was growing as more data was added. It might have only run 10 times when it was first created, but the data kept growing and recently hit the breaking point. With the new query, it should perform well for a long time. Databases can handle large volumes of data within the normal SQL queries, so the select statement should be good for a while. So what did I learn from this experience, and how can you apply it to your own projects? First, don't rely on execution plans for individual queries. They are a great starting point, but just because you don't see any execution plans with a large amount of time taken doesn't mean that there's no issue. Sometimes the real problem is how often your code runs. A fast query that has run thousands of times is still a slow operation. Always understand what a stored procedure or a query is trying to do before making any changes. It took me a while to understand this one, but it was worth it. And wherever possible, avoid loops and row-by-row processing in SQL. It can work in application code, but databases have better ways of processing this and handling the data in sets as opposed to row by row. If you want to get better at writing efficient, scalable SQL, check out my course Write Faster SQL. The link is in the description. This was a simple change with a huge impact. Many SQL performance problems are solved by simplifying the logic, not by some clever trick. If you have a large or an old database you need to understand, you'll want to watch this video next, where I explain my 5-step process for understanding a legacy database. Thanks for watching.